Hey everyone, I'm Surbhi and I'll be your chemistry teacher for today. So students, we'll start a very interesting and important topic today, that is common ion effect from ionic equilibrium. So students, this topic is important from the point of view of CBSE boards, from the point of view of all the competitive exams. So what are we waiting for? Let's start. So before I explain to you in detail about this topic, I'll just explain to you by a very simple instance what is common ion effect. Suppose you go to a party, you have all your friends around and you somehow feel you're not well dressed, and one of your friend enters from there and he's dressed to the occasion, very smart, very suave, and you feel very inferior. Like if you were here before, now you're feeling even more inferior, right? So students, if you understand this hint, this instance, you will go through this topic very easily. Okay, before I explain to you in detail, we just need to understand the two topics, the two terms that we have studied before. One is weak electrolyte and one is strong electrolyte. Now what is weak electrolyte? So weak electrolyte is an electrolyte which does not dissociate completely. It can be a weak acid, it can be a weak base, it can be a weak salt, okay? And if I talk about a strong electrolyte, then that electrolyte is something which dissociates completely, almost completely. Like it can be any strong acid, it can be any strong base, it can be any salt like common salt which dissociates almost completely. So if we understand these two terms, now let's jump into the definition of common ion effect. So when you add a strong electrolyte into a weak electrolyte, okay, such that they have one ion in common, what I said, if you take a weak electrolyte and you are adding a strong electrolyte to it, maybe in small quantity, and the two have one ion in common, then what happens actually is the degree of dissociation of weak electrolyte, it suppresses to even lower level when you add that strong electrolyte. That is what I said, that poor person becomes even more poor. Okay, so common ion effect, if I simply say in definition that you need to write, I would just say that in a weak electrolyte, if you add a small quantity of strong electrolyte such that the two have a common ion, then the degree of dissociation, which we call alpha, becomes even lower, or it suppresses for the weak electrolyte. So that is common ion effect. Now let's understand this by the example of some few suitable examples. Okay, so if I talk about the first example, that is acetic acid and HCl. So students, as you all know that acetic acid is a weak acid because we have discussed this in the chapter before. So acetic acid is weak and HCl is a strong electrolyte. Now if I add HCl to acetic acid, then they both have one ion in common, and that is H+. And actually this is that guy who's smartly dressed, and this is you who's not smartly dressed and not that confident. So if your initial degree of dissociation of acetic acid is alpha, so now it is alpha dash, that is even lower to alpha. If you were dissociating like 5% earlier, now you will dissociating like 0.1% or 0.2%. So your degree of dissociation is suppressed under the presence of a strong electrolyte. This we're gonna study about in this topic. Taking another example, we have a weak base, we have a strong base. Now NaOH is providing a common ion to ammonium hydroxide, and that is OH minus, right? So ammonium hydroxide degree of dissociation is suppressing in presence of NaOH. Another example, if I take acetic acid and a salt like sodium acetate, we all know salts like these, they do dissociate completely almost. So if I add these two together, then they are having common ion of acetate. We will just understand what are the common ions, then we'll go into the details. And then let's take another example. We have taken a weak base, ammonium hydroxide, and a salt NH4Cl. What is the common ion here? Ammonium ion. What is the common ion here? Ammonium ion. Clear till here? And the last example, if you notice, I have taken two salts. One is AgCl and another one is NaCl. You know AgCl is a sparingly soluble salt. Now what is sparingly soluble salt? So any salt which do not dissociates completely, which forms precipitates very easily in water, such salts are sparingly soluble. We will discuss this in the last part of this chapter. And if I talk about NaCl, then you know it is common salt and it is highly soluble in water. So I'll say that this is a strong electrolyte here and this is a weak electrolyte here. So if I mix these two, again if I ask you what is the common ion, so that would be again Cl-. Is it clear from here? Right. So now we'll just jump into the concept behind common ion effect. Like what is actually happening which is letting this alpha to decrease even further for a weak electrolyte. Now that concept is Le-Chatelier's principle. That concept is Le-Chatelier's principle. So we studied it in chemical equilibrium and I'm just recalling it for you. Le-Chatelier's principle says that if a reaction is at equilibrium and somehow because of some external factors like change in concentration, change in pressure, change in temperature, or you might add a catalyst from outside or inert gas, then if your equilibrium disturbs, then to regain that equilibrium back, the reaction goes in that direction where this effect can be nullified. Reaction goes to that direction where the effect of change can be nullified. This is Le-Chatelier's principle. So, what we will be studying in Le-Chatelier's principle here is the effect of concentration of an ion which is coming from outside. Okay. So, let's take a simple example of acetic acid and HCl. Here you already know HCl is a strong electrolyte, right? And acetic acid is a weak electrolyte. Acetic acid partially dissociates to give acetate and H+. Partially I'm saying, and just notice this reversible sign because the reaction has both acetate H+ and acetic acid, especially if I'm talking about equilibrium. So acetic acid is not completely finished here, okay? And if I talk about HCl, since you know it is strong electrolyte, so I'm just using here a single direction arrow which I'm saying that it is just going further and it is strong electrolyte. HCl is finished after some time. So if you mix HCl here, what is actually happening, the right side H+ of this acetic acid is having even more H+ which is coming from HCl. So here H+ is the common ion. Here H+ is the common ion. And the H+ here in this equilibrium reaction has somehow risen because of an ion which is coming from outside. So your equilibrium has disturbed. Your equilibrium has disturbed. So you were at equilibrium in this reaction and your concentration on the product side has risen. So Le-Chatelier's principle, what it says? Le-Chatelier principle says if your concentration on the right side increases, take the reaction backward, and vice versa. If the condition would have been that left side the concentration was rising, then you should have taken the concentration, you should have taken the direction to the right side. Okay, so here since H+ is rising, your equilibrium disturbed totally. So where the reaction will move? It will move backward. So since it is moving backward, what is actually happening, students? Just understand. Acetate and H+, they're just recombining and they're taking the reaction back. So since the reaction is going backward, the acetic acid now is even not dissociating that much that it was dissociating before. Like if it was dissociating say 5% before, now I think it might be dissociating like 0.1%, 0.5%, whatever, but less than the previous degree of dissociation. Earlier it was going forward, now it is not going that much forward because the reaction somehow has shifted backward because of this extra ion concentration on the product side. So your degree of dissociation has suppressed. That's what I said, that if you were here earlier, now you are here in presence of a superior person, right? So I have written in reaction first, as H plus increases in the product side, the reaction goes backward. So here is something that you need to understand, and what type of questions do we get from such topic is the numerical based topics. The numerical based part is very important, and let's just talk about the calculation which is involved in the degree of dissociation of acetic acid. So students, as I said, that if you have the knowledge of weak electrolyte, strong electrolyte, and if till here you have understood what did I say, and if you are aware about dissociation constant Ka or Kb of a weak acid or a weak base, then the calculation or the numerical part will not at all be tedious for you. So in the very next class, we will just understand about how this questions of common ion effect is solved, and it would be very easy and fun for us. So stay tuned. Thank you.